Hi folks, welcome back to the fourth video in the 10.4 lecture series. So we're going to finish off 10.4, which is plane, curves, and parametric equations, with just a little chart to help you recognize the shape of some parametric equations, okay? I personally found this really helpful when I was thinking about in my Calc 2 classes, like how do I know what shape things are? So this is something that, again, I think is sort of an extra layer, but might help you determine, like, okay, how well do you know these parametric equations? So let's start with this first one. If x of t and y of t have the same degree, such as this example, x of t equals t minus 1 and y of t equals 2t plus 4, like t has a power of 1 and then this has a power of 1, so these are both considered first degree, okay? Or maybe you have a case where you have something like t squared and y of t equals negative 3 plus 5t squared. Okay, so we can see that in both these examples, the degrees are the same. Well, in those cases, it turns out that your parametric equation is going to give you a line. All right, so if you look at an equation and the t's have the same degree, you're going to have a line. All right, let's take a look at the second one. If the power of x of t is the square root of the power of y of t, such as x of t equals 2t and y of t equals t squared minus 1. Okay, so like this is the square root of that. Another example might be x of t equals maybe square root of t and y of t equals 3t plus 7. Okay, so these degrees are square roots of each other. In that case, especially when x has the smaller power, you're going to end up with either a parabola facing up or you're going to end up with a parabola facing down. Okay? Now keep in mind where you start and where you stop with your parameters. So if you're given bounds for your t's, you might only get part of your parabola, but the overall shape, if you had every single t value, would be a parabola either up or down. Okay, well, let's take a look at sort of the reverse case. If the power of x of y of t is the square root of the power of x of t, meaning now the power for x is bigger. When we have something like x of t equals t squared minus 3 and y of t equals 2t plus 1. So again, this one is twice the power of this one. Or maybe you have something like x of t equals t to the 4th and y of t would be maybe like 3t squared, okay? In those cases, you're going to get a parabola, but they're not going to be facing up and down. Instead, we'll get part of or all of a sideways parabola facing right, or maybe you have ones that are facing left. Okay, so same powers, you're going to get a line. If the power of x is the square root of the power of y, you're going to get an up and down parabola. If the power of y is the square root of x, you're going to get a side-to-side parabola. Now, let's take a look at this fourth one. If x of t equals a cosine t, a is a number, and y of t equals a sine t, okay, or the other way around, x is the sine and y is the cosine, okay? But the key thing here that I want us to pick up on is all of these have an a in the front. Like the number in the front is the same. So, for example, x of t equals 3 cosine t and y of t equals 3 sine t. Or x of t equals, let's say, 6 cosine sine t and y of t equals 6 cosine t. Okay, so in those cases, the a values are the same. What you're going to get is you're going to get a circle with the radius equals A. Okay, that's pretty handy to know that, oh, you're going to get a circle. Okay, so that's a nice shape to be able to recognize, and sort of setting the stage for Calc 1 and Calc 2, the circle is a really easy shape to find the area of. All right, let's take a look at this fifth one. We see something kind of like this, where we have cosine t and sine t. However, the numbers in the front are not the same. So like this is an A, but then this one is a B, all right? Or maybe we switch our sine and our cosine, but same thing, the first number is different in the x and the y equation. So an example of this might be x of t equals 3 cosine t, and y of t equals 7 sine t. Or we could say x of t equals 8 sine t, and y of t equals 2 cosine t, okay? And in those cases, we're not going to get a circle. This is like example number, the last example we just saw. This one is going to be an ellipse. And depending on your numbers, it could be facing this way, or it could be more of like a Burt ellipse. All right, we've got one last one that I think is, I would say, is on the common list of ones that come up, okay? So in this case, you have a secant and a tangent, or we could flip it and have a tangent and a secant. But very similar to our ellipse, we've got one number in the front of one and a different number in the front of the other. So for example, x of t could equal 3 secant t, and y of t could be 2 tangent t. Or maybe x of t equals tangent t, and y of t equals 1/2 secant t. Okay, so that could be another option. But it turns out in this case, what you're going to get is that third conic section, you're going to end up with a hyperbola. Okay? And again, some of them, they could be opening side to side, all right? Or they could be opening up and down. So good to know that both are options. All right, so let me just zoom back out for a moment so you can see the whole chart. But again, I find this really, really helpful. So I kind of know what shape it's going to be, especially as I'm trying to eliminate the parameters. I can kind of know what my answer should look like. All right, so that's it for 10.4. If you have any questions, send me an email and I'm happy to help you out. Thanks so much. Bye.